Welcome to video 5.2c, another proof of parallel lines. All right, so this is example 2. I'll mark it up as we go along. Given that AP is congruent to AQ and BP is congruent to BQ and BX is congruent to BY and CX is congruent to CY. Prove that PQ is parallel to XY. Okay? Again, it helps my brain if I extend those lines. So extending this line, extending those lines. And what I want to try to do is get those green lines to be parallel. All right, so this problem's a little bit different. It's kind of interesting. There's no way I'm going to get this triangle congruent to that triangle. So if I'm not going to get those triangles congruent, I'm not going to really be getting those angles congruent. So I'm kind of at a loss for a bunch of those theorems. But there's that one oddball. That one oddball theorem said if two lines are both perpendicular to a third line, then those two lines are parallel to each other. So if I could somehow get PQ to be perpendicular to this line and XY to be perpendicular to this line, then I know that these two lines will be parallel to each other. Okay, so that's the route I'm going to go. Technically, there is a way I could get this triangle congruent to this triangle. I could use this by reflexive, side, side, side. Then I could get this angle congruent to that angle. And then I could say, oh, if two angles are congruent and supplementary, then they're right angles. And if they're right angles, they're, I could go that route. But I'm going to use some of that knowledge from the equidistance theorem. This is screaming for the equidistance theorem. Take a look. This point A is equidistant to segment PQ. This point B is equidistant to PQ. So that means that is the perpendicular bisector. Likewise over here, point C is equidistant to the endpoints of that segment XY. Point B is equidistant to the endpoints of XY. So this will also end up being a perpendicular bisector. And I'm going to have my two perpendiculars that way. So that's the route I'm going. I think it'll be much quicker. Okay, so nothing to do with triangle congruence. Just going to use the equidistance theorem twice. Okay, so let's just do chunks at a time. So I'll say AP is congruent to AQ. Given BP is congruent to BQ given. So those were my two equidistant points. So now I can say line AB is a perpendicular bisector of PQ. And I could say, if I call it the kite thing, then perpendicular bisector. All right, so that's perpendicular line 1. Now let's try to get perpendicular line 2. So now I'm going to be on the right side here. I'll use a different color. I'll go red. BX is congruent to BY given CX is congruent to CY given. Again, point B was one equidistant point, point C with another equidistant point. So based on that, I've got BC is perpendicular bisector, we'll call it line BC, of XY. If kite thing, then perpendicular bisector thing. that's going to be perpendicular line 2. And now, based on this step and this step, I can use that, that kind of oddball way to prove lines parallel. So now I'm going to say PQ is parallel to XY if two lines perpendicular to third line, then two lines parallel. And there you have it, another proof involving parallel lines.